Let's take a look at some examples to illustrate what we have talked about earlier. So for example, we have a caplet that caps the LIBOR rate on a 10% on a 10 million notional, and the rate is 3% per year. So the cap rate is 3%, and this caplet is for a 3-month period, starting in 1 year, and the floating rate, discounting rate here is flat at 5%, quarterly compounded. And the volatility of the 3-month interest rate 1 year forward is 30% per year. And there's a zero coupon bond that matures in 1 year and 3 months at a price of $91.69 per $100 notional. So if we are given a question like this, the important thing is to translate the information into the formula that we understand. So if we look at it, a caplet that caps the rate, the floating rate on 10%, on a 10 million notional, so L will be 10, and at 3% per annum, so the cap rate, RK, is 3%, okay? Now the caplet is for 3 months, starting in 1 year. So we're basically looking at TI is equal to 1 year, and the period TI plus 1 minus TI is basically 0.25. So TI plus 1 is 1.25. This zero curve is 5%. And so we have the initial forward rate is 5%, because this is a flat zero curve. Okay, so the volatility is of the 3 months interest rate 1 year forward. So basically the volatility between this period to this period is 30% per annum. So the cap is exactly for this period. So that's why sigma I is 30% per annum. This gives us a discount factor of this zero coupon bond. So basically the price of zero coupon bond is 0.9169. Now with all this information here, we can then just plug in those parameters into the formula. Then we get a D1 and D2. Then we get a price of the caplet is $46,326. Okay, and then if we were to calculate a cap, then we would have a series of caplet, and we just calculate each of the caplet in this particular fashion. Then we add the price of the caplet together to get the price of the cap. Let's now also look at how we can calculate a floorlet, which is actually in a very similar fashion here. Say we have a floorlet that on a notional of 10 million, 3% and cap floor rate in this case, and the starting point is also in 1 year, but for a 3 months period. The floating rate curve, the zero curve, is flat as 5%, meaning that all the future rates are 5%. So the FIs are at the current FI is at 5%. The volatility is 30% and the same discount factor. So you essentially have the same information as we had before. Then we just calculate this with the floor formula to get the floor. In this case, the floor is very small, has a very small value. It's only $480. We can check that the Foucault parity actually holds as well. So what is the swap here? So in this case, we have to have a swap that have a payment at TI plus 1. So the value of that swap is really the 5% minus 3%, which is this is the rate, and its delta I is 0.25, 10 million notional times the discount factor here. So, and if you, so we get 0.04845846 million. And if you calculate your VI minus FI, you will see that you will have 0.046326 million minus this 0.000480 million, and you will have exactly this number here. So the Poco parity condition was also checked out, provided you use the correct swap.